Welcome back. In this lecture, we will learn about column elimination. So, we will learn what is column elimination, how it is beneficial for performance tuning and optimization activity, and we will also learn a scenario when and where column elimination can be a good idea for performance tuning. So, let's start. Let's start with a scenario. So, I have set up some notebook to explain you the scenario and benchmark the scenarios. So let me go to Python version of my notebook, chapter 2. This is my first notebook. This notebook will do the before benchmark, and second notebook, this notebook will do the after benchmark, after implementing the performance tuning idea. And let's start with the first notebook and try to understand what is the scenario. So what is the scenario? Very simple. My team has developed a Spark job. It runs at a scheduled interval, and they are very skilled. So they already learned that if you have a data frame in your Spark application which you are reusing multiple times, then it makes sense to cache that data frame. So that first time it will cache the data in the memory, and all the other queries that are executing on the same data frame will run faster. So they have done that. They have already implemented that technique, but they came up with some additional questions. So the problem statement is we are reusing the data frame multiple times and cached it. So caching is done. We have a data frame. We are reusing that data frame multiple times, and hence we have cached it. However, the first query on the data frame is taking longer than expected due to caching. So obviously first query will take longer time, because for the first time when you run a query on that data frame or some data frame transformations and action on this data frame, it will go pull the data from the cloud storage and then cache it in the memory and then execute your query, right? So we are reading data from the storage, so that's expected to take some extra time. The second and onwards, all the other queries that are running on the same data frame will pull data from the cache. They will not go and read data from the storage, so they will perform better. So that's an obvious thing, right? First query will be slow because cache is a lazy operation. So first time it will pull data from the storage or from the cloud storage, and then second time onwards it will be fast. But they have two specific questions related to the same. Are we caching too much data on our workers? Do we have sufficient memory to cache? And that's a very genuine question every time you decide to cache a data frame, right? You need to make sure that you are not caching too much of data. Let's say you are running on a 4-node cluster, and total memory for the cluster is, let's say, 64 GB, and you are trying to cache 128 GB of the data. You don't have that much memory, right? So over caching or caching oversized data will put some memory pressure on your application, and Spark application will start struggling with the resources, or it will cause various health issues. So they want to make sure that we are not caching too much data on our workers. Do we have sufficient memory to cache? How do we see that? Where do we see that? How to check that, right? That's what the first question is. The second question is, can we improve the latency of first query that performs caching, right? We know the first query which will actually cache the data will be slow, but is there anything we can do to improve it further, right? Can we do some investigation and figure out, is there any possibility we can improve it further? So that's two objectives of goals is there for me to do the investigation. So what I did, I've looked at the main application code, taken out some queries like how they are creating data frame. I've taken out that code, and then 2-3 queries that they are running on the same data frame. I've taken out that and created this benchmarking notebook. I'll walk you through it.